This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
Shubhra Kaur, welcome to Software Engineering Radio. It's a pleasure to have you.
Hey, thank you, Jeff. Pleasure to speak to you as well, and thanks for inviting.
Yeah, so today we're mainly going to be talking about Node.js and the platform and the ecosystem. So why don't you start off by talking about what is Node.js?
Yeah, so Jeff, if you look at it, JavaScript has existed in the browser world for almost a decade now, more than a decade. And all of a sudden, the power of JavaScript was ported over to the server side instead of just making it run on the client side in the browser. And server-side JavaScript is essentially what is now known as Node.js. And this technology stack is helping power the transformation for APIs, mobile, and IoT applications today.
And what do you mean by the power of JavaScript?
Right. So, Jeff, if you look at it, right, like originally server-side applications were built in Java, .NET, a variety of thread-based technologies, right? And that was the way to scale applications. And it's a very mature stack in those aspects. When JavaScript came to the backend, all of a sudden people realized that we can have JavaScript at both ends, both on the server side as well as on the client side. And what this lets us do is build what we call as isomorphic JavaScript applications. And I'll talk about that in a little bit more detail. But what's happening in today's world is, if you look back, let's say, 10 years, right? We were building web pages. We were rendering HTML. And today, the world has changed drastically. We are coding APIs, not apps. So that's why you'll see the terminology that it's an API economy rather than being an app economy. And those APIs need to be lightweight. And those APIs need to be served from the back end as REST. And rather, if you can have the power of serving them in JSON, the consumption of those APIs on the front side, which is also running JavaScript, becomes extremely easy. And Node.js is the technology which is helping you deliver these lightweight APIs rendered as JSON in an extremely high-scale manner, which meets the needs of concurrency needs of mobile applications, IoT applications. So that's what I mean by transformation. And, I can talk about that more from an architecture perspective.
Well, so to boil some of that down, as I understand what you said is much of the power of Node is specifically as a JavaScript backend is basically treating JSON as a first-class object.
Very correct. Very correct. And if you look at it, people used to joke about having a JSON database, right? And all of a sudden, MongoDB emerged, and you had variety of data stores which can let you persist JSON now, right? So on the front end, if you're coding in JavaScript, you can process JSON. If you are on the middleware, which essentially is Node.js, you can generate JSON. And on the back end, if you have a MongoDB type store, you can persist JSON. So now you essentially have what we call as full stack JavaScript stacks evolving, very similar to how a LAMP stack had evolved a few years back.
Interesting. Yeah, because you think about if you have to build like a Java application compared to building an application in Node, it's funny because in a Java application, maybe you would have to use Jackson to parse the JSON objects that come in, and this is actually like it's iconic of like a big annoyance. You have to use this annoying kind of kludgy interface to get to the heart of your JSON objects. And if you're working in Node, for example, it's just so much easier. It kind of comes out of the box.
Exactly. It's a built-in method, right? you can simply do JSON.get, and you can essentially get access to the entire JSON object without having to go through the pain of deserialization, parsing, extracting out, then again converting it into another protocol and sending it over the wire, right?
Right. Okay. And so to separate that aspect of a beneficial component of Node, there's also the single-threaded event loop aspect, which strikes me as a totally different aspect of the ease of programming in Node. So I want to stress the single-threaded event loop aspect of Node pretty early on in the conversation, because I think we'll need to keep coming back to it, because I've been hearing about Node for years, but it's taken me a while to appreciate the kind of the simplicity and the effectiveness of it beyond just the fact that it's JSON. Or that you can use JSON, like I said previously. So explain the single-threaded event loop aspect.
Yeah, so think about it this way, right? Normally, if there's a big confusion about, hey, Node is single-threaded. Is that good or is that bad, right? And is this a bottleneck in scaling Node.js applications by itself? I see it as a great advantage. So if you look at the origin of asynchronous programming, right? If you go back to this has been done in operating systems way back in Windows as well, and original Unix-based handling. And then you saw the emergence of middleware, classic middleware, where
wait. So you're saying the Unix-based model is multi-threaded?
It is, but if you look at how we were dealing with POSIX threads on the Unix systems, right? There was some kind of orchestrator which was dealing with all the operating system threads and delegating tasks for I/O operations. Okay, and if you take the same model over to classic middleware, even in Java land, right? You had message-driven beans, and then classic middleware like the TIBCOs and all those emerged, which were traditionally doing asynchronous message-driven programming. So you were not really, and that allowed them to scale at based on events at an extremely highly scaled model, right? So coming back to the single-threaded nature of it, the way it works is, think about it this way, right? You have a set of requests coming in, and event loop is essentially a postmaster or an orchestrator process. The event loop itself runs single-threaded, but it goes and accepts all these requests simultaneously, but it does not go and take over the execution of the request. It's essentially a delegator. What it does, it picks up an operating system thread and passes off the delegation of the request in terms of I/O operations to that operating system thread. If in the Unix land, this could be a simple POSIX thread. And so a request comes in from a user perspective. The event loop returns what is called as a pointer, which is essentially callback. And then the operating system thread picks it up, does the backend I/O processing, serves the response back. However, the event loop remembers the route, the memory pointer that it used for the callback. So because it keeps in memory all these routes, it can then attach the appropriate I/O response back to the originating request. However, while it's doing this, when it gets a request, handing off back to the POSIX thread, it does not actually wait for that request to complete. It just keeps moving on, right? So first request comes in, delegation, next, and so on, right? So it's obviously, it does not have that traditional waiting bottleneck that we encounter in a Java world or a .NET or a rather thread-based world, right? I myself used to be a Java architect for about 13, 14 years. And classically, the way we scaled JVMs or CLR systems was we operated off a thread pool. So we'll say, hey, you know what? Let's spin up 1024 threads. And when every request comes in, it essentially consumes a thread. And that thread has to make a backend I/O operation. And while that I/O operation completes, that thread is waiting. Now, if you had a lightning fast backend, which would respond in a nanosecond, you are all cool. You'll never run out of, you'll never consume all your thread pool ever, because, as soon as the operation is done, the thread is returned back in the pool. However, the fact is, in production grade systems, backend operations or disk operations are generally slow. And when you do this, your threads are consumed for that time when you are doing that I/O operation. And what happens is if you have huge concurrency on the front end, which now in the new world you will see with mobile apps, right? Because mobile apps, you are getting a lot of tiny events. You're not really serving up web pages. You have things like infinite scroll going on, and you are getting event-based data or IoT sensor-based apps. These are requesting event-based data. So you have huge concurrency, but very tiny fragments of data. The server or the JVM or the CLR won't know the difference between an event which is an HTML page or an event which is a sensor event. It still treats it as a single thread. So what happens is this can easily fill up your thread pool and your threads will start waiting. This is the essential problem that Node.js is solving due to the entire asynchronous way of processing events.
So I think that was a great explanation. And just to drill on that a little bit more, so that our listeners really understand, maybe you could talk in a little more specific detail about an example of I/O that, like a typical example of I/O that Node would be a good solution for. So, because as I understand, the I/O problem was basically the impetus for Ryan Dahl creating Node.
Correct.
So what would be a good example? I mean, you talked about infinite scroll. We could use that as an example, or whatever you think is a good example.
Yeah, so if you are traditionally dealing with I/O, we are here. Let's define what is I/O first, right? What does an I/O operation really mean to Node? Okay, so we all talk about the event loop being single-threaded. However, for memory and network operations, it is actually multi-threaded, right? So it actually uses the thread pool of the operating system threads to do those I/O operations. Now, I/O is anything that is attached to a callback. So when you get a request in Node, and what Node gives you is a callback, and that callback is supposed to do an I/O operation for you. Okay, and that could be a database call. It could be as simple as consuming a backend REST call. It could be writing a file to disk, or maybe reading from disk. Right? It could be a disk operation as well. Or it could be anything to do with memory segmentation, right? So even if you look at garbage collection, the way it works, when you actually instantiate new objects in memory, you have to talk directly with the RAM, right? However, as your objects exit the execution scope of your applications, then the garbage collector takes over, and it goes and cleans up your memory. But the application is no longer dealing directly with the RAM. Post the first allocation of the objects, right? So you are, in a way, these are all general I/O operations. So if I take a use case or what is an application, I'll tell you first what are the application people are building in Node. So Node, I would say, is highly optimal for building, let's say, a WebRTC application, right? So we see them a lot, where you are looking at,
Did you say WebRTC?
Yeah, WebRTC.
What does that stand for?
There's a real-time communication.
Oh, real-time communication. Okay,
yeah.
sure.
So if you're looking at things like building,
So like
video
Facebook.
chats, yeah. So if you're looking at platforms like TalkBox, you name it, right? Like not everything in Google Hangout is was built on Node, but a lot of newer players, right, who are exploring WebRTC as a platform for delivering video and voice content are using Node, right? So that's one good use case. The gaming industry is using Node extensively because, again, it's the same use case of real-time communication using WebSockets, for communication for end-to-end or peer-to-peer communication.
So just to clarify, to give a higher level picture of how this might look, is like the client or the user has, he's got his mobile device. He's got some chat application open, basically, and every time he sends a message to his friend, that chat message hits the server, and then the server receives that message. We'll say it's a RESTful request, and then that hits the Node stack, right, on the server side?
That is correct. However, if you could even implement the server-side logic itself in Node, and if you were able to share the client and the server-side models somehow, right, the state of it, you will be cutting down a lot of latency along the wire. So it really makes it, so that's where you will see Node both on the front end as well as in the back end in case of, let's say, gaming type industries.
Oh, okay.
Okay. So it's essentially, your speed of execution. But I would say these are some use cases, which I've seen different people use innovatively. Some of them are using Node for, let's say, screen scraping and single page apps as well. But if you really look at the number one use case that I would say 80 to 90% of the industry is using for Node.js, that is to build APIs. Okay. And when we talk about APIs, these APIs are powering mobile. And when we say, let's take an example of, oh, I have a mobile application. If I have a big company enterprise and I wanted to have like claim data, let's talk old school, right? We always know the use cases about new school, high tech, innovative companies. But is Node going to really help the mainstream enterprise, right? Saying, hey, I have this business data in a backend system, which is essentially I had written an service-oriented architecture on the backend, right? And I was rendering SOAP to all these web application and web services which were written in Java or .NET, right? Now, those SOAP requests used to take me, let's say 2 seconds, 3 seconds, 4 seconds to render. And I was still okay with them, right? My web pages, I could render static images earlier. And then when the real payload came in, I would then go ahead and, render up a web page in 2 seconds and user won't complain. Now, all of a sudden, that was my online sales. That's how I handle online sales in my enterprise. Now my CMO is asking me, hey, can you give me mobile sales, right? So my challenge has that, okay, I can go and write a native iOS app or an Android app. Now I need to get these app consume the same SOAP messages, right, from the backend. But again, scale at a very high level because, on mobile, my mobile traffic is growing, my web traffic is shrinking. So how do I do that, right? So what Node has essentially become is a glue integrating all these legacy and new tech backend systems with newer front ends like mobile, or what we now call as the front edge, right? You have various interfaces. So how does Node do that? So Node essentially helps you build lightweight APIs where originally used to compose APIs, but Node is taking it in a different way. It's saying decompose APIs, right? So break down your SOAP. Maybe I can talk directly with the database. Maybe you need to store this data in JSON in MongoDB, and I can consume those JSON or that database table or a method within that SOAP operation essentially as a model. And this model I can represent that in JavaScript within the Node middleware. I can apply all schema validation around that, and you will see the emergence of automatic APIs, REST API generation using open source projects like Swagger.
So
Go ahead.
let me ask you something real quick. So do you think that Node is there something like fundamental to writing server-side JavaScript that makes building this interface that's a glue that holds everything together? Is there something special about JavaScript, or is it just the fact that it happened to be that we're writing server-side JavaScript right now, and also we have we have lots of new models for backends, and since Node.js is kind of this just a new framework, it happens to be that people are writing stuff for it that makes it useful. Do you see the root of what I'm asking? Like I'm maybe we're not using the old systems basically because they've developed so much cruft. But there's not anything particularly special about Node.js except that it's the thing that is new right now. Therefore, it's the easiest and the freshest, and it might as well evolve Node.
Well, I wouldn't say that's the use case, right? I would say three things, right, about Node being on the JavaScript. First is you are now being able to isomorphically build applications, right? Not that Node is just new, it's almost been 5 years now, but the adoption curve is just growing exponentially. The second is it helps solve concurrency. That's the number one problem, okay, due to the non-blocking mode of working. Third is it's essentially helping me build full stack JavaScript applications.
Is that's monoglot programming?
That's monoglot programming. And I'll come to that because that's another pattern that we are seeing emerging. And the fourth is that the Node is essentially, from a performance perspective, there are discussions around this, but there is a specific scientific logic why Node, if tuned the best way, can achieve much higher performance than traditional thread-based technologies. right? So those are the 4 drivers. And if you may, I can, touch upon each of those.
Sure.
So let's talk about, we talked about event loops and, asynchronous IO, right? And that's essentially what it is helping you propel. It's helping you support concurrency at a much higher level, right? And this concurrency, this growth is in mobile session, IoT sensor-based sessions. And, Node is exactly tuned to, handle it because, it does not have the limitation of the thread pool, right? It can almost theoretically scale infinitely as long as sockets are available to handle that. Yeah, so the second thing I was talking about is essentially polyglot programming, right? But before I go that, let's look at even the runtime. So we said, okay, asynchronous is good. But what makes Node also faster in terms of performance is that it's not really pre-compiled code, or it's not pre-interpreted code, right? So like if you look at a traditional JVM, you were essentially compiling everything beforehand into bytecode. Okay, and if you're looking at interpreted programs, same thing was happening, but you were essentially doing runtime interpretation. Node uses essentially runtime compilation, okay, or what we also call as JIT pattern, and this is another essence of why it's much faster or much lighter, I would rather say, than a pre-compiled app. Okay, and we'll talk about more detail in how V8 evolved and what's under the line which is making this go faster. But the third pattern we were talking about was polyglot programming. So what happens is, think about Angular, right? Angular has MVC on the front end, or any other, you could be using Backbone, Marionette, you got a lot of MVC choices on the front end. And Node itself is also helping you do MVC in a way, right? Now, the models that you are creating, if you can share that model over the wire, both the state and the spec with the front end, then what you can do is you can achieve use cases like offline sync, right? So think about this way. In the Java days, there was a technology called as JAX-RS, which helped you do remoting, access the server-side models on the client without actually having to write too much stubbing. So new protocols have emerged and new tools have emerged. You might have heard about packages like Browserify, which are essentially letting you run server-side JavaScript code on the client-side client-side JavaScript, right? So you can actually Browserify your entire Node.js application. The second one, we also at StrongLoop wrote a protocol called as Strong Remoting, which essentially helps you share that model. So you can now
wait. Could you dive into that real quick, because that sounds like remarkable. If you can essentially put the server in the browser, could you and I've actually heard people talking about Browserify, but I haven't looked into what that is. So but that sounds like pretty game changing. So what is that?
Oh, it is. So think about it this way, right? I created some data models on the server side in Node.js, right? Those are my data models. And those data models, if you look at Browserify, you can essentially say all these are JavaScript models, and they have to go under some directory structure, right? Basically, create a browser bundle. If you're using a tool like Browserify, you can create the entire browser bundle of those models and use that bundle remotely in your Angular application. So it's kind of an SDK, right? You have to drop that in and use that browser bundle. But what that gives you remote routes. And if you're using a protocol like Strong Remoting, you can do this even without Browserify. But it gives you a way to access over the wire the state of that model and share that model representation on the front end MVC. So, for example, think about it this way. The same model exists on both client and the server, and they are continuously trying to sync over the wire. Okay, client side changes, it goes and syncs the server changes to the server side, and server side changes, it's pushes it out to the client side. So there's always a two-way sync going on. Okay, and it's not really rocket science per se how this is done. It is essentially replication, right? Or you maintain two copies of exactly the same model on both sides. Now,
but this sounds so heretical compared to. I mean, you're supposed to keep the front end kind of lightweight, right? I mean, you're not. I mean, traditionally, right? This is like a separation of church and state kind of thing. Like you don't want to just say we're going to give the browser free reign. We're going to give the browser like as much memory as it needs. I mean, is this just like a fundamental change based on like how much memory the we're giving the browser, or
No. So, I don't want to absolutely make the front end fat, right?
okay,
And so I'm not going to put any of my controller or my viewer viewing or any of the wiring logic onto the front end. What I'm going to do is whatever models that I generated, my data models, only those data model specs I will, and these are like essentially JSON files, right? Each model can be represented as a JSON object. Only those JSON objects I will package and share with the client side.
I see.
So in Browserify, you can say, okay, go and just look up a directory structure. If I keep my JSON objects in a particular directory structure, you can just specifically pick up only the models and not consume anything else. Okay. If you use something like strong remoting, it essentially helps you define the remote routes. And on the Angular side, you can be saying, okay, this model, I'm going to access it local. It's present under this route. Or when I'm essentially setting up routing on the Angular app, I can also say, oh, use a remote route, right? And the remote route, the model is exact same model is present there. Now, what happens is for storage, right? Obviously, you need to keep this in sync, so you need some kind of client storage, right? For JavaScript, it's easy because we at StrongLoop, what we ended up doing, and even like Iris, CouchDB guys, or Couchbase guys actually also did the same, is they implemented what they call as object storage into the HTML local 5 browser. Okay, so that's where the models get saved every time there is an event. Now, if you get offline due to any chance, the model is still saved into the HTML5 browser storage. And when you get online, because it's supposed to sync real time, the model will now try to get synced on the server side. However, if you made any changes on the server side or on the client side, these two models aren't in sync anymore. So when you try to resync over a network connection, then you will have conflict, right? Because the models are not in sync anymore. So now you can also do conflict management on the server side. Oh, whether do you want to keep the server side models? Do you want to persist the client side models, or do you want to override them? Is it based on timestamp? Is it based on the master copy or the slave copy? So these type of implementations have recently started coming in. And I call this what we call as isomorphic JS. They are powering isomorphic JavaScript applications.
Could you give a broad definition for isomorphic JavaScript applications?
I would say isomorphic JavaScript applications are those apps which have their own control and viewing logic, either on the client side, on the server side, but they do share the state and the specification of the models between the client and server.
Interesting. Okay, so and then to regurgitate your explanation of Browserify as a enabler of isomorphic JavaScript applications, my understanding of how you illustrated that was you have basically a directory structure on the client side, and you also try to have that directory structure in sync on the server side, and you constantly have a synchronization going. So if you have some sort of client application where let's say you're playing a game in the browser, for example, and you've got all these objects in the game that are constantly being updated. Browserify would work well because you can look at these different game objects as things that are in a directory structure, constantly getting updated, and you just constantly sync the two. Is that an accurate description?
Correct. You are essentially syncing JSON objects across the wire, right? And wherever there's an they are not in sync, then you'll have to apply some sort of set of programmatic rules to manage the conflict, either on the client side or server side.
Fascinating. Okay, so to bring that back to how Node plays a big role here, do you just have? I mean, is Node just constantly? What is Node's big role here? Is it being the application that's syncing these two, and it's maybe just iterating constantly? Is the single thread of Node just iterating through this directory structure, making sure things are synchronized?
No, Node is essentially going to be your runtime platform for helping you do modeling on the server side in JavaScript, right? Because if you don't do this in JavaScript on the server side, how else are you going to keep persist those JSON and maintain the state? So I'm saying Node is essentially giving you that runtime. And there are a variety of frameworks in Node.js which can help you create this kind of variety of MVC frameworks rather on Node based on top of Node.
Oh, sure. Okay. So that would be like Angular Backbone or whatnot.
Yeah. So similar to like how you have Angular Backbone on the front end, on the back end, you have what I call as ORM based framework, right? Which are essentially doing model driven development. So Express, if you know Express, right?
Maybe you could define for our listeners what is Express.
Okay, so when Node was written, think about Node as your runtime platform, right? It's about 10,000 lines of code. It's a set of core libraries.
So the JavaScript equivalent of a JVM.
Exactly. And what it runs on is the V8 container, right? So what V8 does is V8 gives you the ability to execute JavaScript. But below V8, there is a library called as libUE, which helps you translate the JavaScript into IO or native operations. And then you have a kernel layer, which you are pulling and talking natively, right? So that's where, like, as a company, StrongLoop came into existence, because our core developers who founded the company used to maintain libUE, which was the layer below V8, right? Now, on top of it, when you install Node, you are getting libUE, you are getting the V8 distribution, you are getting a set of core modules. These are called Node Core, which and these are also have middleware components. Oh, I want to connect with a backend. I need a set of drivers. Oh, I need to do basic network operations. HTTP server, for example, is a first-class citizen. So all these libraries are what we call as the core Node distribution. So if you go to nodejs.org and download Node, that's what you're getting, okay? As well as a set of drivers based on your operating system, because you might be installing it on Mac or Windows or Unix or what you have. Now, on top of it, to build any type of realistic applications, folks use frameworks, right? So there are what we call as DIY or do-it-yourself frameworks. At the very basic, these are construction block level frameworks. One of the most popular or the widest accepted one is called Express.js. And Express was built on top of a middleware called as Connect, which helped, and it almost evolved into an ecosystem. If you wanted to build a full stack application, like, oh, I wanted to connect this to MongoDB, I had a package called as Mongoose, a node package, which was packaged within Express as an ecosystem. Oh, I wanted to do templating, right? Then you had packages like Jade, Handlebar, Mustache. It had a lot of web templating support. Or maybe if you wanted to do authentication, it had support for Passport.js, which help you, plugged in into Active Directory, OAuth 2, or do a lot of token validations and all. So Express went on to become the most popular web middleware framework. And I would still say 80 to 90% of today's Node.js applications are built on top of Express. Okay. At StrongLoop, we recently took over maintenance of Express 6 months back. So that's what we are doing from a community perspective, along with maintaining Node Core also. Right?
So let's talk a bit about the V8. So I guess you could start off by talking about exactly how V8 has evolved and how it enables Node to evolve.
So, it all started with, realistically, you'll have to go back a little bit earlier, right? In history. So if you looked at browser, right, there was Netscape Navigator around 94-ish, right? And they did not have JavaScript support. And later on, they added JavaScript. And then IE came.
Didn't they invent JavaScript?
Yeah, the first version of Netscape Navigator did not have JavaScript support. That would be surprising. That was way back in 94. But I think it was like they soon realized that, nah, you need that, right? And then the very second, I think it was like a drop, or like it wasn't a major version release. It came with JavaScript support, right? This was way back in 94. And then, IE came about, with 95, and they still did not have SSL and so on, right? So, by that time, JavaScript suppose was becoming kind of a requirement. And in 98, there wasn't even Mozilla, right? There was something called a SeaMonkey, right? There was an entire application suite. And this was based on the original source code from the Netscape Navigator, right? And then they went on to create a web developer, a communicator. It was an entire application composition package. And that's where, JavaScript started becoming a first-class citizen, right? Because people needed to develop in JavaScript on the browser side. And then all of a sudden, Firefox came in 2004, late in the game, and it said, "Oh, let's make this a little bit more lighter. We don't have to support VBScript, ActiveX, but if we will, support full stack JavaScript, that's fine." Now, when in 2008. That was one time, coincidentally, Chrome Chrome was getting developed, right, as based on a WebKit platform. And this WebKit platform was exactly the same as Apple's Safari browser platform. Okay, so they really did not invent it. It was more or less borrowed. However, that being said, when Chrome applications were written, there was a new OS getting formed called as Chromium, right? And there was also like some lacking support for some .NET utilities. So V8 was actually not created for Node. It was created for running Chrome or Chromium applications, right? As well as supporting some .NET WCF calls. However, then Ryan Dahl originally started the project, and then he had help from other Node core contributors as well. So there was a small team, right? And these guys worked at different companies. And then what happened is libUI was getting created. Because Chrome V8 could run JavaScript, right? So what you needed was some way to hook this up into the native system on the server side. So Bert and Ben, who were the founders of Strongloop, they were working on libUI along with, I think, Fedor from Voxer, right? So there were three major guys working on libUI. So they started collaborating, and we'll say, hey, you know what? This makes sense that V8 should be ported over to the server side, and Node can be support as a container, because not only can it just render the browser, but it can actually now talk with the operating system. It can go do native calls with me. It can do IO operations. So I would say libUI played a major role along with the V8's container, which was essentially high performance JavaScript, right? To port it over to the server side. So that's how I see the entire evolution.
So if you need this will probably illustrate my a misunderstanding something, but if you need V8 to run Node and you don't have V8 on, if you're using Firefox or if you're using Safari, how do you have maybe I'm missing something, like, because my understanding is if V8 is specific to Chrome, and I mean, so how do Node-based applications work in the domain of Firefox or Safari?
Yeah, so essentially, when we talk about Firefox or Safari, you can't really run Firefox or Safari on the server, right? You are essentially running it on the client as a browser.
Right.
Now, Chrome, V8 was not needed for Chrome. It was actually built for Chromium, which was like, they said, okay, can we actually port the browser platform to run on the server side, right? So this isn't really opening up web pages for you, but essentially doing database calls, right? Or maybe doing memory calls, writing to disk, calling other services, right? So you're essentially creating a runtime platform similar to a JVM, right? So this was not possible in JavaScript because, first of all, you needed a container to run JavaScript. So people said, oh, can we port Firefox?
Right, so just to specify, V8 is written in C++. Correct. It's not written in JavaScript.
Correct. V8 itself is written in C++, but it supports the JavaScript runtime, right? And then libUI takes care of the underlying native operations for V8. But that's all C code out there, right? Both these platforms are written in C++. Even libUI is not JavaScript. Okay. So that being said, V8 is not your only choice. Tomorrow, think about it, like on Mozilla, have you heard about a platform called as SpiderMonkey?
Yeah, I have heard about that.
Right. So you can, actually you can port over and run Node in SpiderMonkey too. right? If SpiderMonkey is ported over to the server side. So all of a sudden you get a new platform. Have you heard of Oracle's new platform called as Nashorn? They recently launched it.
It would probably be good for our listeners if you could expound a bit on SpiderMonkey and the Oracle platform that you're talking about also.
Right. So SpiderMonkey, project has been there. It was a very similar initiative, just like V8, to create a little bit more, not fatter, but a richer implementation to letting the browser based or JavaScript based applications do more network related operations, right? And it was you can actually run it on the server side, but it hasn't gone to a place yet where it becomes like a replacement for V8. However, Oracle has invested very heavily since the past 4 years. And we at Strongloop, they collaborated with us as well because we were kind of beta testing and helping them out in a way. So they had launched this Java, lightweight Java runtime platform. Or it's not Java, sorry. They launched a JavaScript runtime platform, which is modeled after a Java runtime platform, but it's very lightweight, and it essentially is a similar implementation as V8, but it can run on the JVM, right? So if you look at V8, you essentially are just running it natively, right? You don't have to install anything to run V8. However, this new JavaScript runtime engine is being called Nashorn. It's spelled as Nashorn, and it can be deployed on Java 1.8 onwards JDKs, right? So it's a JRE sitting on then 1.8 plus JDK. But essentially now it has thrown open the doors for big time enterprise adoption, because enterprises are used to running JVMs, right? They're probably already on 1.6 or 1.7. As they go to 1.8 onwards, they can actually just download Nashorn and run their Node.js application within Nashorn without actually depending on V8, right? So that's a very big announcement that came in recently from Oracle. And they have also developed their projects. One of them is called avatar.js. These are like SDKs that they're developing. And very similar to that, IBM has also developed a Node SDK. But these are essentially for making IBM products or Oracle products, compatible with Node, giving you hooks, to access. Let's say if you're running an IBM application, a business map process management application, can you hook into those with Node.js APIs, right? So both of these companies are heavily developing API hooks using SDKs.
So maybe you could give me some insight into the future of like what is application development going to look like? Like when are people going to choose to use the JVM versus using Node, for example?
If you look at mobile projects today, or even IoT projects, those two, right? Even in the IoT world, IBM has launched a big community project called as Node-RED, right? And there are a bunch of connectors out there, but very, very targeted for IoT. And they have also started integrating with Strongloop's loopback framework, right? Because what we tried to do at our company was we said, okay, Express is all good. Let's build beyond Express. What drove Java? Right? It was not just people don't write plain Java applications. They use frameworks. They use Hibernate, Spring, Struts, variety of frameworks, right? Node.js, you need enterprise grade frameworks. So you will see there's a framework we maintain called as loopback.io. There are other frameworks like Meteor. You might have heard about Meteor, right? And there are other frameworks like Sales.js, right? These are, I would say, a little bit more advanced frameworks. They have ORM capabilities where you can, have a variety of backend data sources, just like any app server. You can connect to these data sources. You can have modeling. You can do relationship mapping, customization. You can manage connection pools. You can do API conversion.
Well, what I find interesting is it sounds like what you're saying. The motivation for moving in the direction of Node as opposed to the JVM is basically you don't care about speed, you care about compatibility.
I would say two things, right? You do care how widely can you integrate in So there are three use cases. One is integration. Third is when you say speed, I take it like it's like a superficial word, because if you look at one of the use cases that eBay and PayPal did, it was reducing the amount of code you needed to write, right? So from there and the number of developers you needed to write this on. So it was more about a productivity, 50% productivity increase for them.
So you're talking about emphasizing development speed over transaction speed.
Yes, but again, that being said, there is a third use case. If you look at Groupon or the implement they have, their use case was mostly performance driven, right? And Node for them was like, hey, if I do, if I have writing, these fat web services in legacy Java or .NET, I won't be able to give the same amount of performance to my mobile clients. And if I write these APIs in Node or these apps in Node, then obviously performance, is at least 5x better for me. And even if you look at, all the real-time industry, right? Be it gaming, transportation, IoT, they are strictly investing in Node just for the performance, the high speed and the performance.
Really? Even what about like high frequency trading? I mean, does it?
Very, very interesting. So that's we should, when we are talking the greatest of Node, let's talk about a little bit, what's lacking in Node, right? So you'd be surprised. There are companies like Dow Jones who have invested 4 years, and I would say 30% of their application stack is now Node.js. Right?
What?
That's correct. Absolutely correct. And we are talking with big financial institutions. Now, there are certain problems we still need to solve, right? Like, what is Node lacking in? Oh, this is all the asynchronous thing is cool. And, we can go deeper when we talk about error management on all. But transaction management or transaction rollback or transaction integrity, these are not very mature in Node yet, right? There have been attempts at doing this using, promises or trying to include, some kind of green threads, right? Meteor tried to introduce green threads to achieve, transaction management, right? But in the normal Node land, Meteor is a very custom framework, I would say, built on top of Node. They had to implement their own models. One of them was called as Node Fiber. But in just the Node land, there are a variety of libraries which are trying to help achieve this transaction management. So that's one area where Node needs a little bit more developing, right? Before everybody can bet like online wire transfers on Node, right? Because, hey, what happens if that wire transfer fails? Can you actually roll it back? Can you audit it, right? That needs then end-to-end transaction stitching. And it's very difficult to do in asynchronous code where you don't have a context of a thread local like you would have in Java or .NET or any other thread-based platform.
Yeah, so I guess let's talk a little bit about the penalties of being in JavaScript world. So there's the classic complaint about callback hell. Could you maybe illustrate callback hell and talk about how that plays into Node or how Node is able to work against that?
Yeah, so if you look at callback hell, what's really happening, right? If you were doing a synchronous processing, right? Let's take a very simple example. I'm trying to read a file, right, from disk, right? I'll say, okay, start reading this file, and I'm probably done. And when I'm done in the synchronous land, I don't care, right? Because I'm waiting for the thread. However, in the JavaScript land, what I want to do is invoke that function. And I want to, when that function is complete, I want to send you a callback, right? Simple. But it isn't so simple, right? Because that file operation could also throw me an error, right? And that error, I want to handle that as in another callback, right? However, if the operation completes properly, then I have the final callback. So now I have a nested callback, right? Now, that pattern can start becoming more and more complicated as I go into the implementation side of it, right? And all of a sudden, when you're trying to say, okay, I might have like 5 nested callbacks, and maybe one of them threw a error, right? Because each of these, the request, the execution request, and the callback, they are processed of separate event loop events, right, or ticks. There is no effective way that if some error happens, that you can do a staggered, long stack trace, right? And figure it out exactly which callback, threw that error, and maybe how to remedy that error. So this causes a lot of pain while really debugging and tracing for errors in application. And this is where, it's also termed as callback hell. Your callbacks within callbacks within callbacks and so on. Try figuring it out, right? So there are certain libraries which took an attempt to solve this problem. One of them was called as promise, right? There was a promise library. So you could promisify a function, right? It had things like, okay, at the basic constructor level, it had like two functions, right? One was like, oh, you fulfill a promise, you reject a promise, and then while that promise is getting executed, that's called the runtime of that promise, right? So if you say, hey, read a file, and in that I'll say, okay, read file, and I'll return a new promise, and within that I'll say, if I have an error, I essentially, that promise will give me a rejection. If I don't get that error, then I assume that it's a fulfilled function, right? Now, what you can do here is you can now implement a try-catch block with this, right? So you can say, hey, create a new promise. Within the try block, you are essentially doing fulfillment. And if the try block fails, you are catching a particular exception. But when you do that exception, you are essentially rejecting it. So you are setting the state of that promised block as failed state, right? And then you can effectively handle error around this, okay? And you can even chain this, right? So instead of fulfill or reject, there are like simple verbs which help you do this. So there is something like, when a promise completes, normally we say that it's has a method called as API called as .done. But instead of .done, you could simply say .then, right? So you can say read file, right? Then function, return the callback. So only when your function is complete, then you can have like all these nested blocks which are defined. Like if you are going through a loop, you can say dot for each. You can have like dot done or dot map or use dot then. You have all these verbs which make your life easier.
You said you used to be a Java programmer.
Mhm.
How does programming in Node compare to programming in Java?
Oh, it's a pain.
It's a pain.
It's a pain, right? And that's where I was giving you this simple example why Promise took an attempt at this, but Promise did not really solve all of this for me, right? Because think about it, in the Java world, I just had to do a try, a catch, and a finally, right? And I did not have to care about how the thread is managed. Okay, the thread execution went through my try block, got an exception, it got caught, and at the end of the execution scope, my finally gets invoked, goes and cleans
Right.
up.
Okay. But I'm sorry to interrupt. But is it a pain because you're not used to it, or is it a pain because it's fundamentally just feels worse?
No, I think it's both. One is not used to it, but again, I'm like overtaking the headache. I have to go and implement libraries explicitly to do what we call as thread tracking or request tracking in my code, which I don't have to write in Java, for example. Right?
Right.
The platform takes care of itself. So there are other ones I would like to specify, not just promises. This is one thing that we are working from the core perspective. It's a library called as Zone. So that's going to, I think, change the Node.js land forever. Zone is essentially introducing thread local into Node.js. Okay.
Oh, interesting.
So by default, we can zonify Express. So you won't even know about that, right? You can just use zonified Express, and you use Express exactly the same way. But there is a root zone, so it's a library which you require, and the root zone gives you an execution. It basically gives you a wrapper around the execution scope. Okay. And then you have these functions which are called child zones, and you have similarly a try, catch, and a return block. And when you are exiting the scope of the function, the return block gets called. It goes and cleans up resources exactly the same way as a finally block used to do in Java, right? So if you have event emitters and all those get cleaned up. And meanwhile, if you throw an error, it does not go and crash your application. That error is captured and it just sets the state of that zone as a failed state. And Zone itself has proper error handling mechanism. It will not go and just crash your application with an unhandled exception. Okay.
Where can people go to find out more about Node or to find out more about you?
Yeah, so we have like a few ones. So we maintain Express.js. If you're starting at the construction block, start there. If you go to expressjs.com, we have all the documentation, specs, libraries as well. We do maintain loopback.io. That's the web page and this is linked from Express web page as well. I would say this is meant as the enterprise ready frameworks, open source frameworks built on top of Express. We are known for technical blogs and articles. We have online study guides. We recommend the best ones. We haven't written all of them. We recommend the best ones from the community. So we have curated that content. Plus, our blogs are like, some companies are known for doling out t-shirts. We are known for doling out technical blogs. We have about 300 plus great technical blogs and white papers written on the strongloop.com site for the community, discussing all these different aspects, right? Both from the runtime as well as the dev time composition perspective.
And how can people learn more about you?
Oh, well.
Or contact you?
Yeah, they can. If you want to send a note at, callback@strongloop.com, right? They can go to our website as well. But I think, just in the community vein, our handle is also called callback@strongloop.com. That's the best way to get in touch with us.
That's very funny. Great. All right. Well, Shubhra Kar, thank you so much for coming on Software Engineering Radio. It's really been a pleasure talking to you.
No, thank you. It's been really my pleasure, speaking with you, and thanks for inviting. My goal and my wish here really is that Node becomes a mainstream technology. So we already see the huge adoption curve, but it becomes mainstream in the next year or so. Thank you.
Interesting. So much. Okay, that's great. Well, I'll talk to you soon, Shubhra.
All right. Thank you so much.
Okay. All right. I'll see you.
All right. Bye-bye.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or Slashdot buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.